How to find the seismic base shear. So let's go through an example. Let's find the seismic base shear of this 5-story condo. So the equation for seismic base shear is V equals CS times W. And W is the effective seismic weight, which is given 12,000 kips. And CS is a seismic response coefficient. For the seismic response coefficient, there are 5 equations. Let's start with the first 3. We have to decide which one of these 3 equations to use, and we'll decide based on the value of t, which is given. So for this example, t is 0.8 seconds. You would use the first equation when t, which is 0.8 seconds, is less than ts. But what is ts? Well, we could check for ts since it's not given here. We need to find what ts is. There's an equation for that. Basically, ts equals sd1 divided by sds. So we have sd1 and we have sds. So for this example, ts is 0.61. Okay, so we need to check is t less than ts. 0.8 is bigger than ts. So we're not going to use the first equation. And for the second equation, t is less than TL. We'll check to see if that is true. TL is 8. Yes, of course. So this equation here is most likely the one we're going to use. Well, it is going to be the one we use because t is not greater than TL. That's the last check for the third equation. So we're not going to use that equation. So now we know we could find the seismic response coefficient by using equation number 2. We know what SD1 is, so we have 0.61 divided by T, which is 0.8, times R, which is given as 8, the importance factor of 1. Okay, plug that in to your calculators, and we get 0.0953. So we still need to check with the other 2 equations for CS. And those provide the lower bounds. So remember how I said there are 5 equations for CS? We looked at the first 3. Now let's look at the last 2 equations. So here we have equations 4 and 5. We will only use equation 5 when S1 is greater than 0.6. So we'll have to test both of these equations. So let's start with equation number 4, 0.044. SDS is 1. The importance factor is 1, and that equals 0.044. Now, is that greater than or equal to 0.01? Yes, it is greater. So let's keep that in mind. Let's keep this value here in mind. Now let's check equation number 5. 0.5 S1 is 0.61 divided by 8 divided by 1. Plug that into your calculator and we get 0.038. So since neither of these lower bound equations are greater than equation 2, we know that CS is equal to 0.0953. So now we could plug that back into our seismic base shear equation, and we get 0.0953 times the seismic weight, which is 12,000 kips. And we get the seismic base shear is 1144 kips. So there's our seismic base shear. Let's do a quick overview of the procedure just so we could really solidify it in our minds. So basically start with the seismic base shear equation. V equals CS times W. Find the seismic weight of the building. It's probably given, or you might have to find it. Then you have to find the CS value, and there are the 5 equations for CS. And basically, you'll choose which one you want to use by analyzing the T, or the natural period of the building. And remember, you could find TS by doing SD1 divided by SDS. And once you decide which equation to use for CS, calculate CS, and then you have to check the lower bounds with equations 4 and 5. And once you find CS, then just plug that back into the base shear equation, and you get your seismic base shear.